All right, now continuing to the last logic. So let me extend this one here. Now we need to indicate the errors. So we have the error formula here, which we know that inside is an SCL formula for the error for calculating the time. And now basically I call it error formula because we need to calculate the time. So don't be confused. Now what we need to do is, let's understand we have two sensors here. So the idea of logic is when this sensor gets on, we run a timer in the PLC. And if the value of this timer reaches to the critical time required plus the error tolerance, then the alarm will be on. For example, the ideal time for the workpiece to reach from here to here is 5 seconds. Okay, so this sensor will start the timer. So if this box or this pallet reaches the other sensor within 5 seconds, then it's okay. But if it takes more, then we will indicate an error. Okay, but just to make it a little bit more flexible, we'll put error tolerance. So we'll not make 5 seconds, we'll make maybe 1 second of tolerance, 6 seconds. Okay, so this error tolerance we can define in this parameter. Okay, this is important. So I'll write error tolerance because we know everything works with the tolerance. So I'll put integer. So I have error tolerance here. Okay, and okay, by the way, let me make it R because we generally make things like this. This is double int. This is how we started. This is real. This parameter is also real. This parameter is also real. Okay, so tolerance is integer. Now what we do, we make a logic here. So let's take some instructions. You should know the addressing of these sensors, and if I haven't shown you already, so let's see, my sensors are connected to I0.5, I0.6 and reset to 0.7. So 5, 6 and 7. So let me see the PLC tags again. Show all tags. So 5, 6 and 7 I have not defined, so let's do it here. 5 was diffuse sensor 1, diffuse. Okay, let me make it I diffuse 1, just I 0.5, I diffuse 2, I 0.6, I reset error 0.7, 5, 6, 7. Perfect. So this is fine. Now we need to read these inputs again. I'll go to the read function, and we also have to, before going to the read function, go to the data block, and we have to define the inputs. That's very important. So I'm coming back to the same steps again. So we have 3 inputs. So we have I diffuse 1, another input. Okay, another input, diffuse 2, input, reset errors. Okay, generally I'm putting I here for the inputs, but you can also eliminate that since it's under the input. You know, this is the good way, but you can use this I when you're talking about the PLC tags. Otherwise you can just remove this I since it's under the input block. I think it's a better way. So I will remove this I from all of them, and the first letter will indicate its nature or data type. So R is real, X is bool. Similarly here, we don't need Q anymore. Remove this one from here. Don't worry about the programming, the tags will be updated automatically. Here it's fine. This is integer, this is real, or if you want you can also put underscore. It's totally up to you, just making it flexible. Okay, so where were we? Okay, we took 3 inputs, diffuse and reset errors. Now we need to make a logic. So coming back to my conveyor, and I need more space. Thank you. Okay, now we need some inputs to make the logic. So I will take an OR gate. Okay, an OR gate will explain. Now one more thing, if I go back to here, Okay, I will come back to this OR gate later because this will be a bit confusing for you. Let's just take one AND gate. And in this AND gate, what do we have? We have the first sensor, and the first sensor is this one. This is actually diffuse 2. So I will use here diffuse 2. So if the first sensor is on, what it will do, it will start the timer. But the sensor will just sense the box, and then the sensor will be off. So we will set a bit, okay, in this case. So I will take one RS flip-flop, and I will take a bit. Let's name it as temporary, and we will define it this bit, not global, but we can do local static. So we define this bit temporary in the dB of this FB. So this comes here, okay, Boolean and the static. Make sure it's static. Okay, so the sensor will set the bit, and this bit will start the timer. So where is the timer? Timer is here, T on, and you take the timer. It has its own data block. Perfect. Now I will come to this PD later. When the timer is complete, the timer completes the time, which should not happen because we don't want timer to complete the time. We want that this box should reach from diffuse sensor 2 to diffuse sensor 1 before the critical time. So what would be this time? So I will go to my error formula again. So the time which we calculated, this is the ideal time. Ideal time, this is the ideal time. But I told you we will take some tolerance, error tolerance. This is important because if you don't take error tolerance, maybe because you can't just theoretically assume that it will reach at the sensor at exactly 5 seconds. It could be 5.05, 5.1 or 5.2 or maybe 5.5. So you need to define some tolerance here. So I will write here time or actual time is equivalent to ideal time plus tolerance time. This is important. Now what is the actual time? You can see here I have written tolerance time, d time in millisecond. So I will take one more parameter, di actual time in millisecond. Okay, this will also be double integer because this is double integer. Tolerance we can also take in double integer to make the data type same. Okay, now what was the actual time? This is the actual time. Come here, this is equivalent to tolerance time plus the ideal time plus the tolerance time. You can also take tolerance just 1000 in your SCL, but I would prefer to use parameters, and this tolerance time we can initiate by 1000, which is 1000 millisecond. Okay, now we have the time in actual time, but in PLC we need to give the time here. So if I give here actual time, this will take the actual time from here basically, and this actual time is equivalent to your ideal time plus 1000 milliseconds. Okay, so this actually will be the milliseconds, which should be okay. All right, so we have reached to this part. Now we need to actuate what? The error. So to actuate the error, you need assignment. Okay, now I'm coming back here to the errors. Which error you want? Let's take error 1. And since we didn't know before what are the errors, so we can write here critical time error, or you can define what you want to say it. You can say delay workpiece error. That error is reaching with some delay, you know, there's a lot of delay, so you can take this error here. Now you should know that these error should go to common, because if you notice here before we have used error common to stop the motor in case of error, to reset the motor, error common. But here we took the error 1, which is this one. So what we do is we make a small OR logic. So here I will take, if any of the error is true, I'm using 3 and 4 because we haven't defined it yet, but maybe in future we talk about something and we realize, oh, we can also add this error. So I just keep it as reserved, and this will give output to assignment, my error common error. Okay, this error will automatically stop the build. Now one more thing, how to reset. Oops, wait, this is wrong. How to reset this bit. So this bit will be set with this sensor, and this bit should be reset with this sensor. Okay, then it will reset the timer and it will start again. But if generally you have a problem and the workpiece is stuck, then you will not go to the sensor and show an object to reset the error. So we will take an OR gate here, because we want to reset the time using the reset button as well. So that's why I took this here. And reset button I0.7. I think we already took it here. Yeah, reset errors. So it will be reset by reset error and another sensor. Okay, because we have to reset the timer. In an ideal situation, this timer should be reset, because if timer is not reset, it will actuate the error, which we don't want ideally. But if there is an error, to reset the timer, we use reset switch here. Okay, so I hope everything is good. We just try this now. So I will reinitialize and load it. This will take a few seconds. And if you are wondering that you need a copy of this program, I will upload this copy and you can find it in the secure download. But you must notice that I am using an old version of this PLC, V13SP1. So it should not be a problem for you if you're using V14 or V15, because these are backward compatibility. You can use it very easily. So this is just for you. All right, let's monitor it, and let's monitor it here. Okay, this is already monitoring mode. Now you can see that here. Error tolerance was 1000. Whoa. This is a lot of time. Wait, what's going on? Time in millisecond. Why this is so much? Because there is no speed given. Okay, this is a kind of... Okay, we can also remove this error because there was no speed given. Let me see. Now it's 8 seconds. All right. So now we see that we have 8 seconds for this box to reach from here to here. And just for the monitoring purpose, I will also like to show you this thing here. Can we see it like this? Oh, we cannot. Oh, this is too annoying. Okay, I will close this, make it half, so that you can see these parameters. Okay, so the actual time, which ideal time was 7 seconds, we added the tolerance. Now it's 8.7 seconds. So within 8.7 seconds, this should reach from here to here. And if you're interested to see the actual time, I can also do that for you, which will be very interesting. So wait a second. Our actual time is coming in this dB. So let's monitor it as well, because you can see this time. Oh, come on. Yeah, here. So maybe here you may not be interested to see the inputs, but we can see the time. This you can monitor the actual time between the sensors. So let's start it now. So I start the motor, and wait a second. Let me put it here. This time should be running. Wait a second, what's going on? Error from last, direction control. Let's see if this timer is getting set. Oh, diffused. Okay, we missed one step. So we have defined the inputs of sensors, but we haven't read in here, which was our mistake. So going back to PLC tags again. Sorry about that. Okay, you can get inside and I will bring it out. Okay, so we need, go down. Diffuse sensor 1, diffuse sensor 2, reset error. Define it like this, and like this. So diffuse sensor 1, this is our guy here. Diffuse sensor 2 and reset error. Closing. Thank you. All right, now let's download it. So I will take it down again and read the timer here. Okay, now you can see the actual time. So this is the actual time by which this box should reach here, and this is the monitoring time. So you can see that this will reach before 8 seconds, exactly at 7 seconds. As I said, that was the ideal time. Now what I'm going to do is I'm going to increase. Okay, let me just complete this box, stop the conveyor, and I will increase the time, and you will see what will happen now. So now the ideal time is, if I start the conveyor, 4.438 seconds. Okay, so you can see the time is 4 seconds, 4.438 seconds, and this is the actual time. And the time for box to come is actually 10 seconds, so I have to wait a bit. So you can see that here. An interesting thing is you can do that in real time. You can change it in real time. So now it's 5.7 seconds. And now I'm going to stop this palette, and you will see what will happen. I will stop this palette here so that it will not reach in 5.7 seconds. So exactly here, just before 1 second, we have an error because our critical time was 1 second. So we have this error. Now to remove this error, I will refresh this simulation. Error is still there, and I pressed reset. This will reset the error. And again, I have to increase some speed, let's say 56%, and press start. So now it's 7.193 seconds for a box to reach from this sensor to this sensor. So this is a dynamically changing this tolerance time, the actual time, based on the speed of conveyor. And this is a very intelligent way to program your errors, because if you do it in a digital or discrete way, then you have to check, oh, how much speed I'm giving. Oh, okay, I have to change the error tolerance based on the speed. You have a chart and you will keep comparing it. I have seen such kind of programming people who are doing it to change the parameter based on speed. So they just move the tolerance time manually. But in this case, it is independent, and it is actually dependent on the speed, but independent of entering it again. So this was about a small example of belt conveyor logic, and basically using the data structures, and that's how we started talking about structure. So this is basically a structure of values and how to use the structure in correlation with data blocks and functions and function block. All right, if you have any doubt in this logic, you can write me a comment, and of course I'm sure you might have some ideas to maybe make this logic more, maybe improvise it more and make it more better. So those suggestions are always welcome. All right, so I hope you learned something up to this lesson. In the next video, I will show you about UDT, and I will tell you why we need user-defined data type. So thank you for watching. See you in the next video.